What we're going to do is we're going to solve this system using matrices and determinants. And so instead of using elimination, we're going to come up with a new way to solve a system. And that system involves, that's the way of solving, involves taking determinants for x and y on the top and bottom of a fraction. So for x, we have a fraction. That's a fraction bar by the x. And for the y, that's a fraction bar. And when we get to 3 by 3s, we'll have x, y, z. And they'll all be fraction bars for them. Okay? On the bottom of the fraction, you simply put the matrix that is formed by the coefficients of the variables. Okay, so if you look at the variables and the numbers in front of them, you see A, B, D, E. Boom, 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 boom. And that is for both variables. The denominator is the same. Of course, your system has to be written in order. It has to be x, and then y, and then equals, and then the number on the other side. If they're not in order when you get it, you have to rearrange things first, and then start the problem. So the denominator of x and y, and then z, when we get to it, is just the matrix that is formed by taking the numbers in front of the variables. Okay? And we all know how to take a 2 by 2 determinant. You just did it on your worksheet yesterday, top half. It's also on the wall, if you forget. For the tops, they have to be different, because if they're not, you're going to get the same thing for x and y every time, and as you know, x and y are not always the same thing. So what we have to do is we have to get c and f involved in this. And here's how you do it. For x and y, you're going to take the c and the f, and you are going to replace the letters in the matrix for whatever you're solving for. So for x, for example, we're solving for x. The letters in front of x are A and D. So we're going to replace those two letters with C and F. And for y, we're going to replace the letters B and E with C and F. Okay? Another way to say that is the C and the F are on the outside of the top. My little green ellipses up there are on the outside of the top, and everything on the inside is the same as the bottom, if that makes more sense to you. Okay? Let me show you. Let me walk up to the screen and show you. Okay, so in the top of the fraction, my C and my F are on the outside, and everything else matches exactly what's below it. Okay? So you write these first, you take the constants, you put them on the outside, and then whatever's on the bottom, you just bring up to the top. That's another way to explain it. And then all you have to do is figure out those 2 by 2 matrices. And you have the solution to the system of equations. That's all you have to do. So let's look at an example. We're trying to figure out what we would put in for x and y to get 6 times x plus 7 times y equals -9, and x minus y equals 5. Both of those things have to happen when I put in a certain x and a y. What are the mystery x and y that work? We did substitution and elimination earlier this year, first semester. Today, we're doing Cramer's rule. So on our setup, the bottom is the 4 numbers that are formed by looking at the letters, which to me looks like 6, 7, 1, -1. Okay, do you see that? Is that pretty simple? You just look at it. That doesn't take any math ability whatsoever. 6, 7, 1, -1. You have to know that if there's no coefficient, the coefficient is 1. 6, 7, 1, negative 1. Now on the top, the negative 9, 5 is going to be on the outsides of the top. And the rest of the top is exactly like what is below it. Like so. And now all you have to do is figure out those 4 determinants and kind of reduce the fractions. So for x, we have on top 9 minus 35, which is negative 26. And on the bottom, we have negative 6 minus 7, which is negative 13. And that's a fraction bar or a division sign, depending on what the numbers are. Negative 26 divided by negative 13 is 2. So x is 2. The bottom of y, we already did. It's the same as the bottom of x. So you really don't need to do the multiplying and subtracting again. The top is 39, 30 minus negative 9. That's the top of y. And then the bottom of y is negative 13. We already did that one because it's the same as the bottom of x. 39 divided by negative 13, negative 3. So the two numbers that work in this problem are x is 2 and y is negative 3. So for a 3 by 3, it's the exact same concept. So looking at the 9 variables, I see 1, 2, negative 1 across the top, 2, 3, 2 across the middle, and 1, negative 2 across the bottom. And that will repeat for all 3 denominators. So you can get all 3 denominators by taking one 3 by 3 determinant. So to do Cramer's rule for 3 by 3, you really have to take 4 3 by 3 determinants. All 3 of the tops and 1 bottom. Because once you find 1 bottom, you've found all 3 bottoms. Okay? They're all going to be the same. So you don't need to write them all out or anything like that. That's just wasting time. On the top, we can start with the same concept as a 2 by 2. That constant column, negative 7, negative 3, 3, will start our problem. And it will end our problem. And in the middle, it goes in the middle. Kind of logical. It's at the beginning for x, or a in this case. It's at the end for c. And it's in the middle for b. Everything else on top will match what is on the bottom. So for A, that would be the second column and the third column. For B, that would be the first and third columns. And for C, that would be the first and second columns. And now it would be a little bit of a process, but now your job would be to find those determinants. Okay? You could do diagonals or you could do expansion by minors. Your choice. Okay? We don't need to go through that process. I'm just showing you how you would do it. The first time we did 3 by 3s, we had to do elimination 3 times to eliminate I don't know if you remember this, but we had to do elimination, and we had to eliminate those 3 terms. So we had that upside down stair step thing going, and that took a lot of time and paper to do. And this, again, is a longer process, shorter process than that, but it's still a little bit time consuming and still some places to screw up.